Effect of acid rain. Acid rain is very harmful to agriculture, plant and animal. It washes away all nutrients which are required for the growth and survival of plant. Acid rain affect agriculture by the way how it altered the component of the soil. It causes respiratory issue in animal and human. When acid rain fall down and flow into the river and ponds, it affects the aquatic ecosystem as it alters the chemical composition of the water to a form which is actually harmful to the aquatic ecosystem to survive and cause water pollution. Acid rain also cause the corrosion of water pipe which further result in leaching of heavy metal such as iron, lead and copper into drinking water. The damage the building and monument made of the stone and metal. Real life example. Real life example Taj Mahal, one of the seven wonders of the world, is largely affected by acid rain. The city of Agra has many industries which emit the oxide of sulfur and nitrogen in the atmosphere. People continue to use low quality coal and firewood as a domestic fuel, adding to this problem. Acid rain has the following reaction with the marble calcium carbonate CaCO3 plus H2SO4 CaSO4 plus H2O plus CO2. The formation of calcium sulfate result in the corrosion of the beautiful monument. Statue of Liberty, which is made of copper, has also been damaged by the cumulative action of acid rain and oxidation for over 30 years and is therefore become green. Prevention of acid rain. Prevention of acid rain. The only precaution that we can take against acid rain is having a check at the emission of oxide of nitrogen and sulfur. We have so far seen the detail of acid rain and its harmful effect on animal, plant and the moments. Being responsible citizen, one should be aware of the harmful effect they cause and of the industries which give out nitrogen and sulfur component wasted unethically. The methane cycle. The methane cycle. What is methane? What is methane? Methane is a chemical compound with the molecular formula CH4. It is the main component in natural gas. Methane is considered the simplest of alkene compounds that consist only of hydrogen and carbon element. Methane is an odorless, colorless, tasteless gas that is lighter than air. When methane burns in the air, it has a blue flame. Insufficient amount of oxygen methane burn to give off carbon dioxide and water. When it undergoes combustion, it produces a great amount of heat, which make it very useful as a fuel source. Methane as a greenhouse gas. Methane as a greenhouse gas. Methane is a very effective greenhouse gas. While its atmospheric concentration is much less than that of carbon dioxide, methane is 28 times more effective, average over 100 years, at trapping infrared radiation. The atmospheric residence time of methane is approximately 9 years. Residence time is the average time it takes for a molecule to be removed from the atmosphere. In this case, every molecule of methane that goes into the atmosphere remains there for 8 years until it is removed by oxidation into carbon dioxide and water. It is difficult to quantify methane emission since sources are spread out over large area and emission value are small and variable in time and space. It is estimated that up to 60% of the current methane flux from land to the atmosphere in the result of human activities. Some of these activities include emission from fermentation process associated with livestock, from cultivated rice paddy, from fossil fuel use and biomass burning, and from landfill. Methane concentration have been increased steadily for the past 2000 years, and despite a decline from 1983 to 2006, it increased again in 2007. Over this time period, atmospheric methane concentration have more than doubled. As with CO2, human activity is increasing the CH4 concentration faster than natural sink can offset it. Further trends are particularly difficult to an- anticipate, partially due to an incomplete understanding of the climate feedback related to CH4 emission. It is also difficult to predict how a human population will grow, possible change in livestock, rising rice cultivation, and energy utilization will influence CH4 emission. The methane cycle. This diagram of the methane cycle illustrates the flow of methane from source into the atmosphere as well as the sink that consume methane. Most people have heard of the water cycle in which water evaporates into the air, return to earth, and then evaporate again. Many other substances including methane cycle this way too. There are many sources that release methane CH4 into the atmosphere. There are also sinks or way that methane is trapped or destroyed. The methane cycle begins in the soil where methane gas is created by microbes. Soil methane is consumed by methanotropes, microorganisms that feed on methane. Methanogens make more methane than methanotropes consume. Methanotropes live in dry soil layer above the deep, wet oxygen poor soil of swamp. Their food bubbles past them on its way to the surface, releasing methane into the atmosphere. This methane joins methane from other sources such as landfills, livestock, and exploitation of fossil fuel. The main mechanism of removal of methane from the Earth's atmosphere is oxidation within the troposphere by the hydroxyl radical. A hydroxyl radical is a negatively charged oxygen from bonded to a hydrogen atom. Hydroxyl radicals are a form of zinc because they scrub the atmosphere clean of pollutant molecules and break them down. For this reason, hydroxyl is known as the clean, cleaner of the atmosphere. After reacting with hydroxyl OH, atmospheric methane is converted to CO2 by a long series of chemical reactions. Some of the methane present in the troposphere passes into the stratosphere where the some process scrub the atmosphere clean of methane there. In an ideal world, methane sources would be balanced with methane sink as with CO2. However, global atmospheric methane concentration are rising as a result of human activity. Scientists are worried because as the planet warms, even more methane will to be released from soil or other place, adding to the global warming problem. Natural sources. Natural sources. Natural sources of methane include wetland, gas hydrate, termite, termites, ocean, freshwater bodies, and other sources such as wildfire. Wetland. Natural wetlands are responsible for approximately 80% of global methane emission from natural sources. Wetlands such as bogs, marshes, ponds, and permafrost provide a habitat favorable to microbes that produce methane during the decomposition of organic material. These microbes require environment with no oxygen and plentiful organic matter, both of which are present in wetland conditions. Wetlands contribute approximately 140 to 280 million metric ton to the global methane budget each year. Termite. Termite. Global methane emission from termite and their mounds are estimated to be about 11% of global methane emission from natural resources, or about 220 kg per year. Microbes in the gut of termite produce methane as part of their normal digestive process, and the amount generated varies among different species. The emission contribute to termite depend largely on the population of these insects, which vary significantly in different regions. Ocean. Ocean. Oceans are estimated to be responsible for about 8% of the global methane emission from natural sources, or between 230 ton per year. The source of methane from ocean is not entirely clear, but two identified sources include the anaerobic oxygen-free digestion in marine zooplankton and fish, and also from methane produced in sediment and drainage area along coastal region. Methane hydrate. Methane hydrate. Methane hydrate. Global emission from methane hydrate account for approximately 5% of the global methane emission from natural sources. Methane hydrate are molecules of methane that are frozen into ice crystal. We are not sure exactly how much methane is trapped in methyl hydrate or how much is in danger of escaping. Overall, the amount of methane stored in this hydrate globally is estimated to be very large, making the potential for the release of large quantity of methane a real possibility if serious breakdown in the stability of the deposit were to occur. Human sources. Human sources. Human activity that produce methane include fossil fuel production, the livestock industry, rice cultivation, biomass burning, and waste management. These activities release significant quantities of methane to the atmosphere. Landfills, landfill methane is generated in landfill and open dump as waste decomposes under anaerobic condition, oxygen free. The amount of methane created depend on the qua- quantity and moisture content of the waste and the design and management practices at the site. Landfill in region with dry condition are not as productive as those in area with high moisture content. In 2012, landfill contributed 102.8 metric ton of methane to the atmosphere. Fossil fuel. Fossil fuel. Fossil fuel are formed by natural processes such as anaerobic decomposition of buried, buried dead organisms. Fossil fuel contain high percentage of carbon and include coal, petroleum, and natural gas. Methane is the primary component of natural gas. Methane is released during the production, processing, storage, transmission, and distribution of natural gas. Because natural gas is often found with oil, the collection and combustion of oil also contribute to the total methane emissions. In addition, methane trapped in coal deposit is released during normal mining operation in both underground and surface mine. According to the 2013 IPCC report, the combined retrieval and use of fossil fuel contribute approximately 85 to 100 million ton of methane of the atmosphere. Livestock. Livestock. Domesticated livestock such as cattle, buffalo, sheep, goat, and camels produce large amount of methane as part of their normal digestive process. In the large first stomach of this animal, microbial fermentation convert feed into the product that can be digested and utilized by the animal. The process produces methane as a byproduct, which is exhaled by the animal cow birth. Methane is also produced in smaller quantities by the digestive process of other animals, including human, but emissions from these sources are significant. Livestock contributions are balanced between 85 to 95 tg. 1 tg is 1 trillion metric tons each year. Wastewater treatment. Wastewater treatment. Wastewater treatment. Wastewater from sewage is treated to remove soluble organic matter, suspended soil, pathogenic organisms, and chemical contaminants. This treatment process can produce methane emission if organic ingredients in the wastewater are treated without oxygen, and if the methane produced is released to the atmosphere. In addition, the sludge produced from some treatment process may be further biodegraded under anaerobic conditions, resulting in methane emissions. Wastewater treatment adds approximately 12.8 metric ton of methane each year. Rice cultivation. Rice cultivation. Methane is produced during flooded rice cultivation by the decomposition of organic matter in the soil. Flooded soil are ideal environment for methane production because of their high level of organic substrate, oxygen poor condition, and moisture. The level of emission depends upon soil condition and production practices as well as climate. There are cultivation practices that could possibly be helpful in reducing methane emission from rice cultivation. Without them, rise production at between 7.4 metric ton per year. A sudden stop in the emission of methane is an unlikely scenario, but there is potential for reducing emission. Recent data show that the short lifetime gases, which include methane, peak earlier and drop away rapidly. This suggests that policies targeting them should lead to noticeable reduction in atmosphere condition concentration. Reducing emission of methane could be valuable mean of showing global temperature rise. The greenhouse effect.